Today we want to review drawing nice graphs of sinusoidal functions. We're going to practice drawing our base graphs again, and then we're going to talk about how we can modify our base graphs because we want to use these to model a bunch of situations. So let's think about the things that we remember. Remember, when we're splitting up our axis vertically, we need to mark a halfway and a 1, and a negative half and a negative 1. That is, vertically, we split the top and the bottom in half. So we look for the halfway mark to the top and the halfway mark to the bottom. Horizontally, we're splitting in thirds. So I mark my graph at 30, 60, 90, 120, 150, 180, 270, and 360. So I'm making 3 marks horizontally, but 2 marks vertically. Thirds horizontally, halves vertically. Oops, halves. The progression is always top, middle, bottom, middle, top, middle, bottom, and we just pick where we're starting. We want to remember that cosine starts at the top. So we're going to remember that cosine starts, and we put it in quotes, cosine starts at the top. And that tells us that cosine of 0 is equal to 0. Sorry, cosine of 0 is equal to 1. Normally I start with sine, which always messes me up when I switch to cosine. Cosine of 0 is equal to 1 because cosine starts at the top. Then in every quadrant, we go down to the middle, and then down to the bottom, back up to the middle, back up to the top, and that's one cycle of cosine, the x-coordinate traveling around the unit circle. So there's the top. The middle is cosine of 90 is 0. The bottom, cosine of 180 is negative 1. Back to the middle, cosine of 270 is equal to 0. Back to the top, cosine of 360 is equal to 1. We get all this information from cosine starts at the top, and knowing that our default amplitude is equal to 1. Middle to the top is 1, middle to the bottom is 1. And our default cycle, our default period is 360 degrees, going around the circle 1 time. Then we want to fill in another layer of detail. We know that 30 degrees off the middle is where we're going to be at 1/2. So 30 degrees from the middle will be at 1/2. So that gives us more detail. Instead of just drawing a line going down, then a line going up, that's going to give us some bend to our graph. So 30 degrees from the middle, we're at 1/2. That means that cosine of 60 is 1/2. So at cosine of 60, that's why we did thirds, 30, 60, we're at 1/2. And then 90, 120, we're at negative 1/2. So 60 and 120 are 30 degrees on either side of the middle at 90. The other middle is at 270. 30 degrees before 270 is at 240. So at 240, 30 degrees before the 270, that's when we'll be at 1/2 again, or negative 1/2. So cosine of 240 is negative 1/2. And then 30 degrees after 270 at 300, we'll be back to positive 1/2. So 30 degrees on either side of the middle, that's where we hit our plus and minus 1/2. Let's make sure that we're all going in the appropriate direction. Then our strategy for drawing a nice sinusoidal function is to connect the middle, the 1/2, and the negative 1/2 with lines. Just draw nice lines. They're not actually perfect lines, but they're really close to being lines. So then we connect with lines, the mids, so then we connect with lines going through the mids. Then we're going to draw our peaks and valleys. We're going to want to make sure that when we hit the top and the bottom, we're going to draw the function nice and flat. But then draw your peaks and valleys. Draw peaks and our valleys. We just kind of like bend these through the valleys, make sure it's flat at the bottom. And then we'll draw peaks at the tops. Our top, middle, and bottom, that we're just using our default amplitude of 1. So our default amplitude is 1. And the amplitude is the distance from the top to the middle, or from the middle to the bottom. The default for y equals cosine theta and y equals sine theta, the amplitude is 1. The length of one period is 360 degrees. So our default period is 360. Our default amplitude is 1. This is for cosine theta and for sine theta. Being able to draw a nice, it's dark in here. Being able to draw the graph properly with everything spread out nice and evenly is going to help us remember our values and our quadrants. Remembering our values and our quadrants is going to help us draw the graph nice. And that's going to help us remember our unit circle, which is going to help us remember our graph, which is going to help us remember our values and our quadrants. This is like the new times table, but for trigonometry. It's just stuff you're expected to know at this point in your mathematical career. Any questions? Let's practice this going through a sine. Let's draw a sine graph. So let's roll. So I'm going to put my y-axis. I'm going to make sure I mark a 1/2, a 1, a 0, -1/2, and -1. So I'm going to use halves vertically. Then horizontally, I'm going to split thirds. So 30, 60, 90, 30, 60, 30, 60, 90, 30, 60, 90, 30, 60, 90. So that's 90, 180, 270, 360. A couple more for extra space. And then here we can draw one cycle of sine. So theta is getting stretched out along the horizontal axis. We're still going to have our amplitude up here of 1. And our amplitude also at the bottom, from the middle to the bottom of 1. Notice that on the top and the bottom, I'm both labeling these as 1 because the amplitude is the distance from the middle to the top. And when we talk about distance, we just always have a positive value. Like it's 5 miles between Skyline and my house. It's not -5 miles from my house to Skyline and then +5 miles from Skyline to my house. We just call it 5 miles. One cycle or one period will be 360. We're going to want to label our starting points, and we're going to remember that the sine, the default sine theta, starts at the mid going up. So sine will start off at the mid going up. So at 90, we're at the top, back down to the middle going down, then down to the bottom, back up to the middle going up. And that's one cycle, up, down, and up again. That's one cycle of sine. Assigning numbers to this, since the sine starts at the middle and we've got this graph, that helps us remember our values. That helps us remember that sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360, we're back up to 0. Middle top, middle bottom, middle. One cycle of sine. The middles are all those zeros. 30 degrees on either side of the middle, that's where we hit 1/2. So 30 degrees from the middle from 0 is 30. That's where we're at a half. The next middle is at 180. So we're at 1/2 at 150 and negative 1/2 at 210. So we get that sine of 30 is 1/2. Sine of 150 is 1/2. Sine of 210 is negative 1/2, because now we're in the third quadrant. And then sine of 330 is negative 1/2. 30 degrees away from the middle. That's where we're at 1/2. We're trying to get the nice bend for our sinusoidal function. Next, we follow the same directions that we did for cosine. We're going to connect through the middle with just lines. So connect through the middle with just lines. Then we're going to attach our peaks at the top and our valleys at the bottom, making sure they're flat. So the way we can aim is we think about moving flat, but then bending up to meet that line. Head flat, but bend up to meet the line. Our little peak at the top, we start off going flat, but then we bend to meet the line. Leave the top flat and then bend to meet the line. So we still connect with lines through the midst, put peaks at the top and valleys at the bottom. Any questions? So this set of instructions, connecting with lines through the midst, that works for both. And then we draw really nice, that helps us draw a really nice sinusoidal function. It's unlikely that this is going to be like a question on a job interview where you're like going to Google, you're like, "Well, draw us a nice sinusoidal function." And then you're gonna be like, "Oh, I'm glad Leach prepared me for this." It's Google interview, so it's probably a trick question. Which means it's silly. I don't like trick questions on tests. Any questions about drawing nice sinusoidal functions? Let's get your top, middle, bottom, middle, top, or middle, top, middle, bottom, middle. Then get your halfway points. Your halfway points are 1/3 of the way off of the mids. 1/3 of the way off the mids, that's where you're going to hit your 1/2s. So halves vertically, thirds horizontally. There's 4 quadrants, so you need 12 thirds going horizontally. If you want to think of splitting horizontally into 3s, splitting vertically into halves, those are the easy ones to find. That way we don't have to mess around with exactly landing on where 0.7071 is or where 0.8660 is. We'll get that bend kind of for free once we get the line segments through the middles and then draw our peaks and valleys nice and flat at the top. Because there's a lot of stuff that we're cramming in here, like the 0.7071 for the sine of 45, and then the 0.8660 for the cosine or for the sine of 60. The halves are easy to locate. It's easy to take a length and estimate where the half is. It's easy to take a length and estimate where the thirds are. Any questions? Depending on how you draw the side portion, I can tell how you fold your t-shirts. Because if you fold your t-shirts in like a store style where you like, where the neck part is in the middle and you do it in the thirds, then you'd be like, oh, no problem, I can split this into thirds. If you're like struggling to figure out where a third is, that's because you fold your t-shirts in half. And so you have like a crease going right through here. You know what I'm talking about? And some of you are like, oh, why do you fold your t-shirts? Just shove them in the drawer. And some people are like, oh, no, you hang your t-shirts. And some of you even still are like, oh, why are you doing your own laundry? Don't you have staff for that? All right. Next up, we want to start taking these base graphs. We want to think of these sine theta and cosine theta. I want to think of those as like base model graphs. Amplitude is 1, period is 360. And I want to start using multiplication to change things. So cosine theta and sine theta have amplitude of 1 and a period of 360. I want to start making alterations because that's too limited, right? We can't just always have everything with an amplitude of 1 and a period of 360. So, I didn't preload them on my calculator. Big disaster. So I want to see what they look like. I want to see what my graphs look like of cosine and sine. So I want to make sure that I'm in degree mode because I'm going all the way from 0 to 360. And so I want my calculator in degree mode. And then I want to make sure that my window is set up right. So I got all these preset windows, and I'm going to use the trig window instead of the standard window, or the square window, or the decimal window, or just the box. We want to use the trig. And then hit enter. And then it'll draw our sine and cosine. Ooh, what's all this calculator here? Oops, cosine is blue, but sine should be red, apparently. There we go. So if you don't happen to have your TI-84, super colors, you can use a better graphing calculator, which would be Desmos, either the app or the website. Let's see. The wrong colors as well. So Desmos you could use in a browser, graph stuff there, or you can use your calculating machine or the Desmos app, which is free. So it's even, not only is it a better graphing calculator, it's a cheaper graphing calculator. Here's what we want to do. We want to see what happens if I start making changes using multiplication. So I just want to pick one. I'm going to pick cosine. And along with cosine, I want to see what happens if I graph these functions. I'm going to change some things with multiplication. So I'm going to do 2 times the cosine of theta. I want to look at these 3 graphs. Oops, stop sharing. Let's take a moment and see what happens if I put a coefficient outside of that cosine. If I multiply by something outside. So I'm going to grab my calculating machine. I'm going to turn off sine. I don't need that for now. But I'm going to graph 2 times the cosine of x. What does it look like happened to this function? When we put the 2 out in front of the cosine, what does it look like happened to the function? Notice that it still goes through 0 at the 0 points. That makes sense. If cosine of something was 0 before, multiplying it by 2 isn't going to change anything. But look at what happened at the top and the bottom. Here, when cosine of 0 is equal to 1, but then we took that and multiplied it by 2. So now we're up here at the top is now at 2. And same thing happened here at the bottom. Cosine of 180 is -1. Cosine 2 times the cosine of 180 is -2. We've taken all the y values and multiplied them by 2. So the top is at 2, the bottom is at 2. The way we could summarize this is by saying that the amplitude is now 2. That's the change that happened when we multiplied by 2. But we also notice that nothing happened horizontally. We still started off at the top. Drop down to the middle, then to the bottom, then to the middle, back up to the top. We didn't change anything horizontally. The period is still 360. The amplitude changed to 2 because we multiplied all the y values by 2. Any questions? So speculate, what do you think will happen if we multiply the y values by 3? Oops. Any ideas? Let's got to redraw all of them. So there's our generic cosine. Here comes 2 times the sine, or times cosine. And here comes 3 cosines. Chat has it. The amplitude is now 3. We've taken all the y values and multiplied by 3. The period doesn't change. Notice that the places where it crosses the x-axis or the theta axis are still at 0. Because if we take 0 and multiply by 3, we still end up with 0. But the top originally was 1. We've multiplied that by 3. The top is now at 3. So this changes our amplitude to 3. But the period is still 360. Any questions? So, a question in the chat says, can the period ever change? Yes, we can change the period. We haven't got to that part yet. So if we have a 0.5 times the cosine of theta, we can speculate that the amplitude is now going to be 0.5. But the only change we made was in here, was the coefficient. So the period should still be 360. And that's what happens. If I graph 0.5 cosine x in orange, then I get that 1/2 for an amplitude. But the period is still the same. Any questions? Let's go ahead and turn these off. So we've got the 2, we got the 3, we got the 0.5. Now I want to change the coefficient to a -1 to see what that does. So here's the graph of cosine again in blue. And here comes the graph of sine. We've taken all the y values and multiplied by -1. So where the graph crosses the theta axis, still 0, because 0 times -1 is 0. But instead of starting at the top, instead of cosine of 0 equal 1, since we've multiplied by -1, cosine of 0 is -1. Our amplitude is still 1. Our period is still 360, but we ended up starting at the bottom. So the amplitude is still 1. The period is still 360, but this negative means that we started at the bottom. We just take the top and multiply by -1, and we end up with the bottom. The opposite of the top is the bottom. That's what multiplying by -1 does. It makes opposites. Any question? Is everybody okay? It's so super organized and predictable. It's good that it's predictable because we're trying to learn it. It's not like modern storytelling trend where you just try to just usurp the audience's expectations at every turn. It's like, oh, calm down. Sometimes you just want things to be normal. Lean into the audience's expectations. You know what I mean? It'd be like trying to make a Fast and the Furious movie and say, this one, we're not going to have any cars in it. It's like, well, that's not how this works. It's like, well, but it will usurp the audience's expectations. It'll be a twist. Like, well, now, then it would not be a Fast and Furious movie. It would just be, like, I don't even know. We're all fans of the Fast and the Furious, right? It's like the greatest movie franchise of all time. I want you all to know that at the end of Fast and the Furious 5, Fast 5, I predicted that Fast and the Furious 10 would take place, at least partially, in space. And I called it 100%. Now, you might be thinking, wasn't that Fast and the Furious 9? Michael, it is the 10th movie. Because don't forget Fast and the Furious, Hobbs and Shaw. Anyway. I think we're running out of people to put in those movies. I'm actually expecting a call. And I go, Professor Leach, we need you for Fast and the Furious 13. I go, all right, I'll be there. Because that would be awesome. Especially if I get to be the villain in Fast and the Furious 13. Because then, even if I get killed in Fast and the Furious 13, I get to come back and join the team in Fast 14. Right? It's like, oh man, I'm sure glad we killed off that Professor Leach fella. And that's when I would walk in the room. Are you sure about that, Dwayne "The Rock" Johnson? And then Vin Diesel would be like, oh, I guess he's family now. Then we'd all have a Corona, barbecue something. I'd be like, that's cool. You got any tofu? And they'd be like, well, get the fuck out of my movie. You know what I mean? Anyway. I don't know if it's my favorite movie franchise of all time, but I do consider it to be the best. Because they never try to do anything. I mean, obviously they try to one up the previous movie. So I don't know where they're going to go now. They're going to be driving through the face of the sun. I'm going to have to slingshot my charger around the sun. By the way, if that happens, I want a piece of the action. So I will be expecting a check. I never got my check for telling you to put Fast 10 in space. That's why, by the way, they made Hobbs and Shaw and they didn't give it a number. So that wouldn't be Fast 10. Fast 10 wouldn't be in space and they wouldn't return my calls. This is why they're all like, don't answer the phone. So I just started calling all of it. Called Vin Diesel. And when do I get to be in that movie? Called it 10 is in space. Vin Diesel was blocked by them. Same with Jason Statham. And Dwayne "The Rock" Johnson. Stop stalking us. I'm not stalking you. I'm just like pitching my next movie idea. You know what I mean? But yeah, greatest movie franchise. They don't ever try to do anything fancy. They just say, this is what we're going to deliver. It's just another one. Stuff go boom, car go fast, excessive amounts of shifting. It's like, oh, dude, it's an automatic transmission. Why did you change the transmission? It's a Charger. The Chargers all ship with automatic transmissions. You don't get a manual in a Charger. It's like a tunk, 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 tunk. But then again, they must be changing their transmissions because sometimes you'll see a car in reverse and it'd be like all like, oh, motherfucker, did you put 2 reverse gears in your car? And it's like, apparently, I've only got 1 reverse gear in my car. Yeah, that's fancy. What are we talking about? Oh, yeah. The greatest movie franchise of all time. See what happened with Sine. All right. Let's take a look at a graph of sine of x and see that similar things happen. So here's our graph of sine x. It's going to start in the middle, go up, down, and then up again. So it's middle, top, middle, bottom, middle, top, middle, bottom. And we're thinking of starting off at 0. Sine of 0 is 0. If we multiply, we should expect the amplitude to change. So 3 sine x. That's exactly what happens. The period doesn't change. The amplitude does change because we're multiplying all the outputs by 3. So the amplitude does change. We are going to want to know what happens if I multiply by a -1. What happens if I change the coefficient to a -3? And so we'll see that the amplitude is going to be 3, but instead of starting off at the middle going up, we're going to start off the middle and head down. So the number is changing the amplitude and the sign changes to the opposite of the start. So let's summarize that in words. So for -3 sine theta, our amplitude is 3. The period stays 360 because we didn't do anything horizontally. But now, instead of starting off the mid going up, we're starting off the opposite of the mid going up because we multiplied by -1, and that's what -1s do. They change to the opposite. So we start at the mid going down. Because the opposite of the mid going up is the mid going down. Questions? Earlier, there was a question. Does the period ever change? And yes, it does. As I pointed out that the amplitude was 1 and the period was 360. I brought that up. That's like foreshadowing. We know that this is going to happen. It's like, has anybody ever heard of Chekhov's gun? The idea in storytelling is if you put a gun on the table in Act 1, it has to go off by Act 3. Otherwise, it shouldn't be there in the first place. This is unless you're making Game of Thrones season 8, in which case you just have all kinds of stuff all over the place and this is never addressed again. I would take my ancestral weapon, sword, from the wall. And then never mention it again. So we're also going to be using multiplication to change things. So let's get into our graphic. We'll just base this one on sine x. So we're going to start off with sine x, and we're going to want to produce some graphs. This should be very predictable what's going on. I'm going to do some multiplication, but instead of the multiplication happening out here, it's going to happen in here. So we want to graph sine of 2 theta. I want to still use multiplication, but I want that multiplication to take place before the sine. And now we will see things happen with the period. Actually, I don't want the red one, I want the green one. Oops. So notice that this sine at least seems to be running around the circle much faster. How much faster? Looks like twice as fast. Look at what happens in one cycle of sine. Remember, the blue function is sine, and the green function is sine of 2x. While the blue function does one cycle, mid, top, mid, bottom, mid, the green function did 2. Mid, top, middle, bottom, mid, top, middle, bottom, mid. It did 2 cycles. The amplitude is still 1, but the period is now half of what it of the 360. It's doing 2 in 1. So the amplitude is still 1. But the period is half of 360. We could think about the sine going through theta twice as fast. We go around the circle twice. We go around the circle twice as fast. We'll do the same thing again. I'm going to change from multiplying by 2 to multiplying by 3. I'm going to turn off the green one because this one gets messy. But we're going to look at sine of 3x. So here's our normal sine of x. And then here comes sine of 3x. It's going up and down much faster. Notice in that one cycle of sine of x, sine of 3x goes through 3 cycles. It's going 3 times as fast. So our amplitude is still 1. And our period is 1/3 of the 360, or 120, because I've got to fit 3 cycles in 360 degrees. Our default is 360, and I've got to go around 3 times. We're going around the circle thrice as fast. Any questions? Change again. Because I'm super predictable. Now I want the sine of 0.5 x or theta. We're going to interpret this the same way. We're going to go around the circle half as fast. So what's the period going to be for sine of 0.5x? We're going around half as fast. Here comes sine x. And here comes sine of 0.5x. Notice that where sine of x did one cycle, sine of 0.5x only did half a cycle. The cycles are taking twice as long. The amplitude is still 1 because I didn't put anything on the outside. And the period is going to be 720. I want it to look the same as what we did up here. I had, when it's a 2 in front, 2 theta, I put a 1 over 2, 360. When it's a 3, I put a 1 over 3 times 360. So for this, I'm going to put 1 over 0.5. Ooh, that looks terrible. Times 360. One divided by 0.5 is the same as multiplying by 2. Dividing by 0.5 is multiplying by 2. Just like multiplying by 2 is dividing by 2. Sorry, multiplying by 2 is dividing by, I think I just switched the order, not the operation. And now I can't remember what I led with. Multiplying by 1/2, I'll look at it, is the same as dividing by 2. Dividing by 1/2 is the same as multiplying by 2. And we can interpret it the same way. We're going around the circle half as fast. So if we're going half as fast, one cycle takes twice as long. If we're going 3 times as fast, one cycle takes 1/3 as long. Any questions? Is everybody okay? Let's summarize. I didn't do negatives here because I like to keep that a surprise. I'm going to put it up here. The coefficient of the trig function, that's going to tell you the amplitude. The coefficient of theta is going to tell you the period, but it's not going to actually be the period. It's going to tell you take 360 divide by b, that's the period. So the period will be 360 divided by b, which will be the coefficient of theta. The amplitude will be the absolute value of whatever's in front. If A is negative, then we use the opposite start. If A is negative, then we use the opposite start. Start at the bottom for a negative cosine, start at the mid going down for a negative sine. The number part will tell you the amplitude. And if the coefficient of the trig function is negative, then you're going to use the opposite start. Any questions? Is everybody okay? Both of these adjustments are made with multiplication. I just multiplied by some constant. When I multiplied outside the trig function, it had a vertical chain. When I multiplied inside the trig function, it had a horizontal chain. How's everybody okay? They're about to not be okay because I'm about to release a bunch more quizzes called Know Your Values, and you're going to have to figure out reference angles, and you're going to have to know your values of trig functions with 30, 45, and 60-degree reference angles and your quadrantal angle. That's why we did so much work with the graphs, to help us remember our values and our quadrants, to help us remember our unit circle, to help us remember our values and quadrants, to help us remember our graphs. All three of those things help us remember the other two. Each one helps us remember the other two. Any questions, comments, deep thoughts? We didn't take a break today, so let's take a break until next Tuesday. And we'll come back and we'll talk a little bit more about this multiplication, using multiplication to change things. That's it for today. That's it for this week. I'll see y'all on Tuesday. Everybody have a good weekend and thanks for playing.